AgroScout is revolutionizing field crop scouting with its autonomous, cloud-based artificial intelligence system for quickly detecting, identifying, and monitoring crop disease and pests. According to the UN, growers lose 20 to 40% of crops to disease and pests, and manual, sample-based scouting doesn't provide full coverage. Existing remote sensing techniques, which have been developed in recent years to address irrigation and fertilizing, are not sensitive enough to accurately detect diseases and pests on time, even when incorporating satellites planes for scouting. AgroScout's autonomous system uses off-the-shelf drone and camera technology to scan entire fields at minimum cost from the first acre. Integrating weather and other data from existing sources, our highly affordable solution harnesses artificial intelligence to speed up plant-level scouting and to pinpoint the affected areas and recommend treatment. By providing early detection and identification of disease and pests, AgroScout's comprehensive system reduces scouting expenses, optimizes chemical pesticide use, and has the potential to significantly increase both crop quality and yield. Join our scouting revolution. AgroScout. Detection done right. Go to agro-
Okay. Okay, so I'll say a word about myself. Again, my name is Simcha. I spent the last 20 years developing new technologies in the IDF, most of them in the intelligence, a lot of remote sensing, computer vision, 360 imagery, deep learning, and things like that. And in the last 2 years, I've taken what I've learned there to the agricultural world, trying to use those same kind of methods in the agricultural world, which mainly is still stuck in the 50s that we heard before. Not much has happened, really. I am the founder and the CEO of AgroScout, the movie you just saw, and maybe I'll talk a bit about that later. So, since the beginning of time, we know that people have tried to understand the year, when they're going to plant, when they're going to harvest. A lot of them did it on little writings and looked at the stars. The Antikythera mechanism is actually the most advanced and interesting one, built more than 2,000 years ago. It's the first mechanical computer that can predict the whole cycle of the sun, the moon, and the stars, which allows them to understand when the beginning of winter or spring will be, when they will be doing the harvest, when are they going to be planting. If you look at the history of agriculture, until 1800, nothing really changed too much. The same amount of population, the same amount of growing of crops like we heard before. The real change, like was said before, is after World War II, when we start to use a lot of chemicals for fertilizer and for pesticides. And even though we had tractors in the beginning of the 1900s, real tractors in a lot of fields after World War II. And in the last 20, 30 years, we talk a bit about precision agriculture, trying to get a more precise treatment to crops. And I'd say in the last few years, remote sensing from satellites, from planes, and the newest things obviously are robotics and artificial intelligence. Unfortunately, the robotics part is still very, very not out there. Every other day I see a little movie of an autonomous tractor, and John Deere has these fleets of them. When you go out to the real fields, there are not any real robots there yet. So we see that in the future, but that revolution is what is going to allow us to grow more. And as you heard, we need to grow much more, because not only has the population grown, we're going to have another 2 billion people in the next 20 years that we're going to have to feed. And we're at the limit of the agriculture that we know today. If you look at those big crops like corn and wheat and soy, they haven't changed in the last 5 years. They haven't grown. Okay? If we look at the world crops, and let's just put everyone on the same countings, 1 dunam is 1,000 by 1 meter. An acre is 4 of those, and a hectare is 10 dunams. Okay? So I'll talk in acres if it's okay with you. According to the UN, 20 to 40% of the yield is lost every year to disease and pest. After we put out all the chemicals, all the outputs, everything, we still lose 20 to 40% at a time that we actually need to grow much more. So something is broken in the system. just a word or two about how we're using artificial intelligence. Artificial intelligence is a form of computers doing simple, intuitive things that we do. In this case, it identifies a license plate. In the more sophisticated machine learning kind, the developers are telling the algorithms to look for specific patterns, a face. If you see two eyes, a nose, and a mouth, it means there's a face in that picture if you see them together. When you use your camera on your phone to take a picture, it already shows you a little box on the face. It doesn't necessarily identify who that is, but it simply identifies it's a face. The most intriguing and interesting part of this is deep learning. In deep learning, we just take endless amounts of data, like we heard before, and some like I'll show now, and we let the algorithms find those patterns by itself, things that we don't even think of when we look at this information. The simple case of e-commerce is we have this user buying sports goods. So the computer understands he's an athlete. It doesn't know what an athlete is. It doesn't care. It just knows to offer this person other products that are considered athlete products. But what happens when this athlete starts buying a totally different kind of product? In this case, fruits and vegetables. It'll seek out to its other mass amounts of data of what other athletes bought and find patterns that we can't even think of. In this case, it found a similar pattern between athletes that are similar to our buyer, and I want to recommend the orange juice. How is it helping us in agriculture? So we heard one example before, and there's a lot of great examples now and more of them. The only major challenge that we still haven't get together is we don't have something called smart home or smart city in agriculture. It's a lot of segments and silos of great startups that has to get together if we want to be able to really grow more. In these two cases, you see one company that their robot goes around the greenhouse and picks the tomatoes. So it's identifying the tomatoes by itself. It's identifying if they're ripe or not, and then picking them. On the right case, it's detecting how much fruit's on the trees at a very early stage of the season, which allows the grower, they sell the fruit in the beginning of the season. They have no idea how much to really be growing. The biggest challenge we have today is the endless amounts of imagery we're getting. Planet Labs, that was mentioned before, has 120 satellites around the Earth. They cover every inch of the Earth every day. Even if we wanted to exploit that information, all of us together, we'd see just a fraction of it. Only analytics can do something with that kind of imagery. I just looked up the information the other day on how many drones were sold today around the world. Anyone? How many drones were sold around the world? How much? Anyone else? Just in the US, there's more than 1 million drones. Most of them DJI small drones. DJI actually dominates 85% of the market. There's about 3 million of them around the world. If you took all the satellites together and all the planes that are doing remote sensing, at the most you'll get to a few thousand. So a totally different era than we ever had before. And this allows us to do things that we couldn't do before. This is also a potato field in North America, about 125 acres or 600 dunam, whatever you're counting this week. And that scout, the agronomist that goes out into the field, he only has 20 minutes, 30 minutes to look at the plants. And he's a very expensive person. Even if he's just a scout and not an agronomist, he's still a very expensive person to walk the fields. I've not yet met an agronomist or a scout that has enough time to walk the fields as he would like to, as he's needed to. And if you remember the 2 billion acres, only a fraction of that is actually scouted in the world. That's the reason in Israel, in the US, we grow 20, even a bit more tons an acre of potatoes, while in China, the biggest grower of potatoes in the world, they grow 10. They grow 50% of their potential because they just don't have the agronomy. The challenges with this kind of data that we're collecting, and we collect thousands, millions of images, just a drone like this flying around. I will give the drones out, but please give them back, okay? This one won't take off. It doesn't have any wings. So we use commercial drones. They have amazing cameras, 20 megapixel cameras, 1-inch sensor. We fly very low over the canopy. We get a 0.5 millimeter pixel resolution. But these images are very big. We have to upload all of them to the cloud. Why do I see you don't see? Okay. This is the kind of images we're looking at. So if you remember before, we can't really use those simple forms of AI because it's not a license plate. Even if all these pictures in the first one or in the last one or the second one, the early blight, I can, if I'm an agronomist, I know what that disease is. It doesn't really look the same. Okay, if I go to this next picture, this is all of one disease, and we have thousands of taggings of this. Very few of them look the same. But when the agronomist looks at it, he says, yes, obviously this is that disease. So this is our challenge. And the only way we can deal with this challenge is with deep learning. We let the algorithms by themselves find the patterns in this data. The other thing we do is we first train the algorithm to find the healthy things. Okay? We look for the clean leaf. We look for the earth. We want to get rid of all of those millions of images of leaves that are okay. And then we ask it to start telling us the kind of problems it thinks it is. Very challenging because it's very different. So we'll fly these drones once or twice a week over a field depending on the crop, collecting hundreds of images in each field, but we're not going to do full coverage. If you try to full coverage with a small drone that has like 20 minutes of hundreds of dunam or 100 acres, it'll take you a whole day. I have to match myself with the 20 minutes the agronomist would be in the field. Okay, so I fly around in checkers. I fly around like a Superman agronomist would want to fly over the field. So I fly very low, I stop where he wants, and I take the image. All these images go up into the cloud, and then the algorithm can try to detect if there's a problem or not. In some of the cases, like in this case, this is the Colorado potato beetle. We only had a few dozen images of this beetle, which actually causes a lot of damage, but they just pour out so much chemicals, we couldn't find any of the beetles. So this is actually a field. You see on the right, that's how an image looks from the drone. We fly like just a few feet, 1.5 meters above the crop, and we tag all those beetles. This field is not being treated for the beetle. So we can collect thousands of taggings of this beetle. Okay, so before the algorithm will know there's a problem, it won't necessarily know what the problem is. So there's so many problems, so many diseases, so many pests. It'll take us forever to train it for all of them. But mostly the grower himself already, when you bring up just the 5-10 images would have problems in, they know how to detect, with their eyes they see what it is. So first we'll detect all the problems, and then if it's a major disease or disease or pest, then it will also say what it is. We look at a lot of field crops, but I show this slide because of the cannabis, not because the cannabis is an important crop. It's not, and it's also a very small crop in global as far as global numbers are. But it's a very interesting crop. If you grow cannabis in a greenhouse, okay, that plant will probably see an agronomist every day because that plant is worth thousands of dollars. Not because it needs more treatment or agronomy than a carrot plant or a tomato plant. But the tomato plant costs 2 cents, okay? But they all really need that same kind of treatment. And if you look at the yields that we get in a cannabis greenhouse because of the agronomy, that's what we actually need to be doing in 2 billion acres around the world. And the only way we can do that is using millions of drones, people flying by themselves. Software does it, but with their own drone and using things like AI to detect that. In our case, we just use the commercial drones and the commercial smartphone. We do the analytics. We'll embed all the other information, and we'll tell the grower or his agronomist where he has problems. So if I compare to the other solutions out there, okay, Taranis is a very interesting, a very good company. Someone will be talking right after me also about that. They put a sensor on a plane or a big drone, and they'll also get that kind of resolution. But how many planes can Taranis have? 100, 200, 300? How many acres can they cover? How much money is that going to cost? Okay? How much money does it cost to send a plane to fly over a field? How much money are they taking from each grower? They take a few dollars an acre. Okay? The soybean grower in India that has 20 acres, he has zero precision agriculture. He has zero imagery from satellites, and he has zero agronomy. The same as most of the growers out of the 500 million growers of the world. Okay? Because they just can't afford that. On the other hand, there's millions of drones out there. I don't like this sentence, but it simplifies it. It's the Uber of remote sensing and the ways of agronomy in the field. Okay? Now erase that sentence and we can go on. So if we really want to change and grow more like we need to in the next 20 years, we really have to bring all these companies together, okay, in one kind of a smart agriculture environment where all the information is going from one to the other. The agronomist, the grower, each one is getting the information that he needs, regardless if he's a small grower in India or a big grower in South America, and allowing them all to use those technologies that are already out there. We already have them in the cannabis greenhouse, okay? And it allows us to move from something that we didn't have before. Today, when they go out to the field, they find one leaf with the disease, they treat the entire field because they're doing statistical scouting of the fields. Wherever they are doing scouting, most of the world, they're not doing even scouting. In this area, it allows us to go to an almost plant level scouting and plant level treatment. It's a very interesting Israeli company, SkyX, that has a fleet of spraying drones, okay, which is not so great for a big field. But once it has this kind of intelligence of where to go, then that fleet of drones becomes very interesting, okay, and saving money. Questions? Yes.
Can you use it for algal farm?
For what?
Alga.
What's alga?
Alga farm. Like, algae.
It can be used, the AI part of it, which is the major part of it, can be used for anything visual. So anything you have agronomy. The reason we chose these crops is because we saw the correlation between how important the agronomy is and how visual it is and how much it helps the crop. So if it's something visual that someone goes into this place and looks at it and sees it, we can train the algorithm to do it. If we have a way to take those images, a drone, a camera, a robot that's driving down the greenhouse, then the algorithm can do it. Yes? How do we get what?
How do you get your label data, and also do you take into account the variation in intensity, sun, weather conditions? You know, it's
For drones, 10 to 2 is the optimal time to take imagery. Specifically for us flying very low over the canopy. We actually tested different hours of the day from the morning and the evening. It didn't really change anything for the algorithms. Okay? The taggings are done by people around the world. Our first adapters are actually the scouts that we want to replace. Don't tell them. But they're actually doing the job. They use the drone. They're in the field anyway. They look at a few things in the corner of the field. The drone flies around the entire field. They go back to the office. They look at the images. They tag it for themselves. And they're working for me. Don't tell them. And that's how we do it. And we also pay people to do it. So, yes.
How well do the drones handle environmental conditions like rainfall or strong wind
I'd say they're the least sensitive to that challenge.
compared to agronomists?
Yes.
Okay.
Compared to the satellite, if there's clouds, it's not going to see anything. Compared to a plane that's not going to take off if there's weather issues that day. When I'm out in the field, I'm out there even 20 minutes without rain, I do my scouting, the drone will fly. It's not going to fly in the rain, this one. There are military ones that do, but the imagery is not going to be relevant. So we're not going to fly if it's raining. These DJI drones do very well even in very strong wind, and the imagery is still very good and stable, but it'll lower the battery time. Yes. Yes. Yes.
You haven't compared your technology to the technologies now existing that use the smartphones themselves to analyze the crops and do similar analysis that you do, but based on the visual of the farmer, the problem, and then takes the photo and uploads it to some application.
I'm agnostic to where the information is coming from. So if the farmer's taking images like I showed the smartphone before, if he's taking images, then I'll do the same analytics on that image. What the drone, what the robot allows us to do is cover 100 acres in 20 minutes, taking images of thousands of plants. The grower is going to take pictures of 10 plants. And most of the growers, they know what they see anyway. They don't need me for that. But in China, for example, they have someone in the pivot that just takes care of the water coming in and out. He has zero understanding in agronomy, but he has a smartphone. So I do want him to take some images of problems that he sees that it's not green, and we'll do the analytics for that. But it's only going to be a few images. I'm talking about millions of drones taking trillions of images around the world. So that's just the bigger and most efficient collector. But if it's a camera, we have a cannabis greenhouse. Not here. I don't have any in my bag. In South America. There we're going to put a few cameras, GoPros, just to look at each plant. We'll have a camera on each plant. Just because it's worth it. So I'm agnostic on how I get the imagery. The analytics doesn't really care. Just has to be high resolution. Yes, anyone upstairs? Yes. Can't hear. Yes, very challenging. So now, the question is, how do we deal with all the data and upload it into the cloud? So one, Oracle, which adopted us, gave us a very good solution in the cloud, so we don't pay that much because we're a startup. But they all do the same kind of stuff. It's very cheap to upload and keep it in the cloud. The connectivity is a challenge. But as we go in the future, it's less and less a challenge. In some cases, we'll do the analytics in the field itself. So it can be on a laptop, and it'll be taking out all those green leaves, like I showed before, somewhere. I showed that we train it to see everything that's okay. Just 1 second. So we can easily just do that first thing. What is normal? And then the only thing that's going up into the cloud will only be those polygons of the problem. We haven't done that really much yet because the connectivity in North America was okay, and also here in Israel. But if we do have to, we'll deal with it. Yes, anyone else up there? Yes.
How different is the solution for different?
How? How
The
different?
difference,
Yes.
the solution between different crops. The solution is really similar between soybean and wheat, or it's vastly different.
So it depends on, the process is the same process. We have to cover the field for as much as we can over a season, collect enough imagery of the problems, not just clean fields, and tag thousands of times the problem. As soon as we have a few thousand taggings of a certain problem,
But you need different taggings for different.
yes, yes. So
You don't have transfer learning.
yes, so the first stage would be just show me what's not okay, and that's easier, and that's the same pretty much for all of them. I wouldn't say exactly the same, but that's the easier stage of adding a new crop. And then the specific disease and pests will only do the major disease and pests in that crop that are causing the damage. A lot of these things are very visual and easy to see, but they don't treat for it. It doesn't do anything. It doesn't matter. Yes?
What's your success rate in terms of how much does the agronomist still need to go to the field once your solution is deployed?
So depending on the crop, and we did a lot in potatoes, less in the other crops, some of the things are not visual. Some of the things they have to take out of the ground and look at. I'd say that's 30% of problems, depending on the crop. But in 70% of the things, we'll show a very high level of a problem, okay? Not necessarily telling what disease it is and what pest it is, but that there is a problem in the field. You have to understand that in most of these crops, as soon as they detect it on one leaf in the entire field, today, they spray the entire field. So we're better than that. But in the future, I want to be at the plant level almost. So he can treat just a corner of the field or a half of the field. So he's saving money there and using less chemicals. Today, growers in North America, especially processed potatoes, have a problem selling to Europe because they use so much chemicals. So now they're trying to reduce the amount of chemicals through advanced agronomy. Yes? Anyone else? No? Thank you very much.